it to 2. If you use type 1, exactly, by using the word itself, your computer can understand. Okay, and then the next step is augment. So augment is one of the technique that you can use to increase the amount of your data. So augment is just like just now I mentioned that assuming that you have 100 records of diabetes patient, but somehow you find out that 100 records is not much, isn't it? So you can implement augmentation. So augmentation is just like you add slightly modified copies of your records. So for example, from 100, you make it double. Okay, so there are few ways lah. There are few ways in order for you to do augmentation. So in Python, so you can use upsampling to increase the data set. Okay, and then another way is instead of use these 100 records, you can find other related data set that you can use it to identify the patient of type 1 and type 2. And then the next step is shape. So shape here is, for example, you have 101 records. And then in order to classify to type 1 and type 2, you want to divide it 50% and 50%, right? But somehow the record is 101. So shape here is you can remove the last record so that you get an equal proportion. Okay. So next, how you can deal with missing values. So what is missing values? So missing values is considered as values or data that is not stored or not present in your record or your data set. So for example here, so this one is missing values, and this one also considered as missing values lah. Okay, so there are 4 reasons why we might have missing values in our data set. So for example, due to human error. Okay, so normally when we manually key in our data, right? So some of the records might be, let's say when we manually key in our data, we might skip few rows, for example. Okay, so this scenario will lead to empty column. Or maybe you want to key in your personal information in your website. Okay, there's a lot of fields. Okay, but suddenly when you want to key in your IC number, for example, so you encounter the internet problem. Okay, so the website will save your information up until you lost the internet connection. Okay, this is due to human factor. And then the second reason why in our data set or in our record we might have missing values is due to undisclosed information. So for example, like in a survey or in any questionnaire, okay, so you don't want to key in private data like IC number, salaries, or maybe address and so on. Okay, and then the third reason reason why we might have missing values in our record or in our data set is due to non-applicable information. So for example, let's say based on this 1, 2, 3, 4 features, we want to group this feature name, age and location based on gender. But somehow if you look at here, there are one record, there is no information about gender. So at the end you cannot classify or you cannot group the patient according to gender. And then the fourth reason why our data set contains missing values is due to outlier values. We call it as extreme values. So outlier here means in your data set, so you can see that there is a few or there is a data point that is different from the rest of the data. So for example, 1, 2, 3, 4. For record 4, so there is missing values here. So this one is missing values. Record 3. So record 3 we have 1000. So this 1000 we consider as extreme values, or we call it as outliers, because it is different from other. So outliers is considered as extreme values, either it is lower or upper values, whether it is smaller or bigger values. Okay, so literally, if you download this kind of data set that encounter these 4 errors, and if you still use this kind of data set for your next process, at the end you will create an inaccurate output lah. So there are few ways that you can use to handle with missing values. So for example, the first one is to impute or to replace the missing values. So for example, so you can replace the missing values with mean, median or mode. So for example, okay, let's say, so we have name and age here, and we have missing values here. Okay, let's say if you want to replace the missing values by using mean. So what is mean? What is mean? Average. So how to calculate mean? 12 plus 32. So the missing values, we assume this one as 0 lah. Okay, 12 plus 32 plus 0 plus 5 plus 12 plus 43 divided by 6. So mean value is equal to calculator. Or you want to use this one? Calculate now. Calculator. 12 plus 32 plus 5 plus 12 plus 43. 17.33 for mean value. Okay, so if you plan to replace the missing values by using mean, so this 0 value should be 17.33. This one using mean lah. Okay, let's say if you want to replace the missing values by using median. So median, what is the median means? Okay, first you need to sort the value, isn't it? How to sort? 0, 12, 5 0, 5, 12, 12, 32 and 43. So the mean value is, median value is 12. 12. Right. Okay, and then if you want to replace the missing values with mode, so what is mode? Frequency lah. Okay, so based on this record, the frequency is 12. So 12 lah. Okay. There are three ways. Either you can replace missing values with mean values, median, and mode or mode. It depends on you. But for every single imputation technique, you must justify lah. So for example, why you prefer to use mean, why you prefer to use mode, and so on. Question? So we proceed. Okay, and then the second way to deal with missing value is you can delete the observation, or you can delete the variables that have a lot of missing values. So here, either you can delete the records or you can delete the variables. So variables here means you can delete the features or attributes. So this one we have attribute. We have feature name, age, location, and gender. So assuming that all of these four features, you found out that age has more missing values, so you can simply delete these features. Delete features. Or another way is you can delete the record or the rows lah. So for example, row 1, 2, 3, 4, 5. So record 5. So we have 1, 2, 3 missing values. So you can delete the rows. Either you delete the rows or the records, or you can delete the variables or the features or the attributes. So this one lah. Attribute name, attribute age, attribute location, or attribute gender. Either you delete rows or you delete the column. So column, features, attributes, or variables refer to the same thing. Don't ask me later. Okay, and then the third way to deal with missing value is you can keep it. Okay, so for example, so let's say all of these 1, 2, 3, 4 features, and then you find out that you think, based on your research, you find out that gender is important for you to identify the whole insight, so you can keep that. Okay, so there are a few techniques to decide whether you need to keep the variables or whether you can delete the variables or not. So the first, the procedure that you can use to identify, to keep or delete the missing values is by using statistical tests. So you can use what? RMM student? T-test. What else? Z-score. General knowledge lah. What else? Identify the correlation and so on lah. Okay. So for example, all of these 4 attributes, you want to delete attribute or you want to delete feature age. Okay, so before you delete the age feature, so you need to identify either this feature or this variable is dependent or independent. If it is dependent, okay lah, you can delete. If it is independent, for example, you find out that the features age is you find out that the features age is dependent to feature name, then you cannot delete lah. But somehow, if you find out that the age variables is independent, then you can delete. Or you can evaluate the relationship between feature name and feature age. So if you want to measure the relationship between these two, so you can use a statistical test named correlation. Correlation, right? So you can identify the correlation. If the correlation between these two features is high, so that means it has strong relationship or strongly correlated, then cannot delete. If it is low correlation, for example, normally when we want to measure the correlation value, the range is between 0 and 1. If it is near to 1, then it is highly correlated. If it is near to 0, then it has low correlation, then you can delete. But somehow it depends case by case. Question? Okay, and then choosing the right way to deal with missing values. So this one is based on your understanding lah. Assuming that you want to identify the diabetes patient to type 1 and type 2, and then maybe you can interview the experts in diabetes. For example, you can interview the researcher, or you can interview the doctors that has been deal with kind of data set. Okay, so based on their observation, so you find out that all the records is important. So if it is important, based on their knowledge, then you need to keep it. So otherwise, you can delete it lah. So basically, observation is based on the expert. So when you are doing your assignments, right, you need to choose a data set, right? So you are the one who experts lah. Okay, and then few examples here to deal with missing values. Okay, so for example, in record 1, so we have missing values here. So based on this record, so what kind of techniques that you can use to deal with missing values? You want to delete, or you want to impute, or you want to replace it with known values? So which one you prefer for record 1? Delete, replace, impute, right? What else? Null. Of course lah, by default replace with null. And then, so if you get here, we have categorical values here, right? So the mode for this one is single, single, right? The mode. Okay, so the mode for this metastasis is single. So you can replace it with known values, which is single. What the frequency? Okay, and then for the second record, so we have credit bureau score. Because there is not much information about this figure, So instead of if you find out here for the feature credit bureau, it has a lot of missing values. So in this case, you can delete the whole features. Okay, and then for record number 3, just now we have already delete, so no more missing values lah. Assuming that there is no missing value. Okay, and then for record 6, how to handle missing values? So we have 2 missing values. So the first one is for the income, the second one for the marital status. So single lah. And then what about the income? Mean. Why mean? We have mean and also mean, mode and also median. Why mean? Okay, but why? Then you need to find it lah. Okay, so for example, because it is okay, either you can replace it with mean or you can replace it with median, but somehow you need to identify what is the reason lah. There is no right or wrong for this one. And then for record 9, also you can replace it with mean and also median. And then what about record 10? If your features is categorical, so normally we can use mode. For example, category A, category B, and so on, categorical, right? So the highest frequency should be used to replace the missing values. Okay, and then so we have few examples here. Okay, so this one is assuming that you are conducting a questionnaire or survey. So if you write the option is like this, so this one is considered as value observation, because the salary of CEO is somehow might reach 1 million, but somehow for the age, right? So this one is considered as invalid, because nowadays it is quite impossible lah. Quite impossible for a human being to live for 300 years. Not even close, huh? I have one question. What if, assuming that we have column, for example, like 10-year-old kid, is it possible for this kid to have 1 million salary? Are you sure? Possible. Why? No. Himself. Genius. But why? Not logic lah. Maybe this 10-year-old boy is a YouTuber or TikToker. Who knows? Then you need to identify assuming that in your data set you have this kind of information. 10-year-old boy, salary 1 million. Then you need to study a bit lah. Or maybe he is YouTuber, or he is maybe he influencer. He is the influencer, or he inherits his grandfather's so on lah. Okay. Okay, and then so the next one we have multivariate outliers. So multivariate here means the variables or the features that have more than 2. Okay, so for example, if in your data set you only have the information or the records or the data about income, Okay, so that one is considered as univariate. If in your data set you have many other features like income, age, for example, like name and so on, multiple features. So these multiple features, we call it as multivariate. Single features, univariate, multiple features, multivariate. Okay, so in your data set also you might have multivariate outliers. So just like the data set here lah. So for example, here we have outliers and missing values. So this one is considered as multivariate outliers. Okay, and then there are few steps for you to deal with outliers. So for example, you can first think the simplest way is you can calculate the minimum and maximum. So for example, let's say you have a data set about age. Okay, so once you calculate the minimum and maximum, so for example, we have 1, 200, 1,000 and so on lah. Okay, so first thing is you need to arrange the data set. After that, you need to find the minimum. So for example, so the minimum is 1, maximum is 100. And then from this data set, you can identify so which one is the outliers for the age. So based on this one, assuming that this age is for a student who is taking bachelor. So in this case, okay, let's say this one is 23 lah. The minimum value and also the maximum value is considered as outliers. So the minimum age to take bachelor level is maybe 18 lah, 18 years old, right? And then extreme values, either it is lower or upper, is considered as outliers. Outliers. Okay, and then, so another way to detect the outlier, so you can use histogram for univariate outliers, or if you have multivariate outliers, you can use regression. Okay. Instead of using histogram and box plot, you can also use Z-score. So for example, this is the histogram. So from this histogram, so this is the peak of your histogram. Okay, so I draw one, not straight lah, consider just nice lah, the bell curve lah. Okay, so from this data set, and then we can identify the frequency of the age of Malaysian citizen lah, for example. Then you can find out that we have few citizens that falls in this range, 150 to 200. So this one is considered as outliers. So outliers is extreme values. Okay, so based on this histogram, this histogram is right skewness or left skewness? Right or left skewness, RMM students? Right skewness, why? Because this is the tail, right? So the tail is towards the right lah. Okay, so the peak here is mode. Mode right? Median. Median or mode? Forgot lah. Mode the frequency, and then median somewhere here. Median. Mid, where is it? Here or here? Somewhere here. Right? Am I wrong? Okay, so in order to draw a histogram, so you can use the built-in function from your Python. Just call this function. Okay, so next, just now you can use histogram. You can identify the minimum and maximum values. So you can use histogram to detect outliers. And another way is you can use a box plot. So box and whisker plot to detect the outliers. So for example, so this is the 5 summary of your box plot. So for example, here we have Q1, quarter 1, which is 25% of your data set. Okay, so assuming that we measure the data set in percentage, so Q1 25%, and then we have median, Q3 quarter 3, and then the minimum values and also maximum values. Okay, so any values that is outside the maximum or minimum values, so that one is considered as outliers. Okay. So one example here. Okay, so assuming that this is a data set about age lah, age. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So 11. To identify the median first, just now I mentioned that we have 5 summary. Q3, median, Q1, median, Q3, maximum and minimum and so on lah. So first of all, we need to identify the median first. Okay, so this is the median. And then to identify the Q1, quarter 1, so from 48 to 60, we take the median of first half. So in this case, the Q1 is this value. Right, quarter 1, 25% of your data point. So Q3, quarter 3 is here from your second half. 75% of your data. Median 50%. Okay, and then if you get here, we have let's say you want to identify whether your data set contains missing values or not, you can use this formula. You need to find the interquartile range. So interquartile range formula is Q3 minus Q1. So in this case, Q3 is 81 minus 57. So what is the value for your IQR? $81 minus 57? 54? 24, relax. So 24. Okay, and then after you have identified the IQR, then the next step is to identify the lower and upper boundary. Okay, so lower and upper boundary is somewhere here. So this one is minimum is lower boundary or lower fence, and this one is maximum upper fence or upper boundary. Okay, so the formula to calculate the lower fence or the lower boundary is Q1 minus 1.5 times IQR. So what is the value? Upper fence Q3 plus 1.5 times IQR. So what is the value for lower fence? 24? Sorry? $21 and 107. This one 21. Okay, so that means in this case, so assuming that from this data set you want to draw your box plot. Okay, where to draw? So median value is 72. Q1 is yeah, you draw nicely lah, 57. Q3 81, and then minimum values 21 later. Okay, maximum values is 107. Okay, and then minimum values is 21 min 21. So based on this data set, there is no outliers lah, right? Minimum values 21, so outlier should fall to the values that is less than 21, and also to the values that is more than 107. Okay, so question. So you draw your box plot nicely lah. So here, but somehow based on this 11 data point, we don't have any outliers lah. Okay, and then this one we have 11 data points. So what if we have even data point? So for example, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data point. So how to identify the median? So the median is here. 72 plus 76 divided by 2 is equal to 110 divided by 2. What is the final value? 72 plus 76, 110 divided by 2. 74. So the median is 74. So what about the Q1? Okay, so to identify the first half, so to identify the Q1, then we need to identify the first half first. So in this case, so the first half should start from 48 up until 72. First half. And then for the second half, starts from 76 up until 88. Because just now median is somewhere here, between 72 and 76, right? So for the first half, starts from 48 to 72. So the Q1 is 57. Q3 is 57 plus 61 divided by 2. 59. And then for the Q3, this value, so 81 plus 85 divided by 2, 83. Then after you have identified Q1 and Q3, then you need to calculate the IQR lah. Q3 minus Q1, so 81 minus 59. 22, 22, and then lower fence, and upper fence, Yeah, what is the value for lower fence? Huh? 53. 83. Upper fence? Q3. Oh, sorry. Q3 is 83. And then lower fence? Two six. 26. Okay. 26 upper fence. The value for upper fence? Why? 21 190 119. So 119. I trust you, huh? Then after you have identified Q1, Q3, and also the IQR, you can draw your box plot. So of course you need to have your box here, and then must label the median. So the median value is 72, and then Q1, Q3, maximum, and also minimum values. Okay, and then the maximum values is 119, and then the minimum values is 26. Okay, so based on these 12 data point, there is no missing values because all these 12 records, which starts from 48 until 88, falls within the area of your whisker. So this is what we call as whisker lah, this area. So for example, out of these 12 records, you will have a data set or a data point that is 120, for example. So 128 is outside, somewhere here outside, right? So in this case, 120 is considered as outliers because it falls beyond the maximum values. Which part? The second data set or the first one? IQR. This one is not 22. So what is the value? 24. You calculate lah. I trust you. Okay? So in order to find the lower fence and also the upper fence, so lower fence, we use this formula Q1 minus 1.5 times IQR, and then for the upper fence Q3 plus, because it is on the upper part, so we use plus symbol, plus 1.5 times IQR. Okay, so Q3 we use plus symbol, Q1, which is referring to the lower fence, we use minus symbol. So different lah. So can we proceed? Okay, and then another way for to detect the outliers, you can also use Z-score. So this is the formula for your Z-score. So we have X here. So X here is your data point as usual. So in this case, so this 48, 52 is your data point lah. So your data point. So mu here is the mean value, and then this one is what? Sigma. Sigma symbol is your standard deviation. Okay. Okay, and then in order to identify the outliers, there is a range there. So for normal practice, if you get the values of your z-score here, which is more than 3, so that one is considered as outliers. So this is the normal practice lah. But somehow in your, let's say if you want to try another values, for example, like you want to try another values like 3.5 or 4, so can. But somehow this one is a common practice already approved by researchers lah. Okay, so and then so this is your data point, and then you want to identify whether in this data point we have outliers or not. Okay, so this one is based on the previous formula for z-score. So which one? We got ID1 up until 6. Which one got outliers? Got number 6 outliers. This yeah, z-score absolute values. So this one outliers lah. Common practice, the z-score value more than 3 considered as outliers. So later on when you do your assignment, it depends on you. Either you want to use histogram, or you want to use z-score or other techniques lah. Okay, and then let's say if you have multivariate outliers, there are a few ways. Either you can calculate the outliers individually. So for example, you want to identify the outliers for each column or each features. So maybe you use z-score also can. Or another features like you want to identify the outliers for column salary, for example. So you can also use z-score, which means you use the method to identify outliers one by one, or you can use other methods called regression. Okay, so for example, so regression here, so if you take here, we have you need to inspect, is there any observation that have large error? So for example, you can use residual. So for example, let's say you want to measure the temperature for tomorrow. So based on your findings, okay, based on the actual, so the actual value for temperature is 37.5, for example, for tomorrow. Okay, but somehow you predict the next the net temperature to be 38, but when it comes to tomorrow, it is just 37.5. So residual here means the deviation between the actual values versus the value that you predict. So in this case, the residual values is 0.5 degrees Celsius. So this one you will learn about this one later in detail during your practical lah. Okay, and then so instead of using residual plot, so you can use other machine learning techniques to deal with outliers. So for example, you can use decision trees, neural networks, SVM, and so on. Or you can even use z-score for truncation. So in this case, you draw your bell-shaped curve. So any values that is less than this area or more than this area, so this one is considered as outliers. Okay, and then the next one, we have standardizing data. So standardizing data is you want to scale your features, or you want to scale your variables so that it will fall to similar range. So for example, assuming that you have multivariate data set, you have gender, and then you have age. Gender and income. But somehow you find out that the gender normally female and male, or 0 and 1, like this, right? But for the income, the range, maybe some of the human will have 1 million, 100,000 and so on. The range between gender and income is different. So in order to make it standardized, so you can scale this value. Okay, so there are 3 techniques for you to standardize your data set so that you will fall within the same range. So the first one is you can use min-max normalization. Okay, so this is the formula for the min-max. Or you can use Z-score standardization. So this is the formula for Z-score. Data point, mean value, and also standard deviation. Or you can even use decimal scaling. So this one we will cover later. And also the categorization part. We also will cover this one later. And then the last one for today. So quiz 1, I have already posted the question in your Google Classroom. So you can do it now.